Well, f of x equals 3x plus 2. We know this limits. What is that limit? 14. We know that, right? I mean, it makes sense, right? Now, what does that mean? That means f of x can be as close to 14 as you want, as long as x is close enough to 4, right? Does that make sense? Okay. So here's a question. How close does x have to be to 4 if I want f of x to be at most 2 units? F of x can be as close to 14 as I want. Let's say I want it to be within 2 units of 14. Right? I should tell you how far does x has to be from 4. So that f of x will be at most 2 units away from 14. Okay, let's look at this with a picture. Okay. That's the picture for 3x plus 2, right? Okay. So I want f of x to be within 2 units of 14, right? So pictorially, that means I want f of x to be somewhere here, right? Well, if that's the case, according to that picture, x has to be where? Around here, right? If x is around here, then I'm guaranteed that y or f of x will be within 2 units. You see that? As a matter of fact, I can make f of x closer to 14. I can ask this question and say, what if I want f of x to be at most 1 unit away from 14? Then I can do something similar and figure out where x has to live, right? So that, how close x has to be to 4 so that I have that desired distance. And that's just a rough estimate. I can actually do this with basic algebra. Here's the calculation. Start from what you want. That's what you want. That's the direct translation of this. I want f of x to be at most 2 units of, I should say, away from 14. That's what it says, right? Right? Okay? So, what am I getting to? What do I want? What is this here? How close does x have to be to 4? What is the ultimate goal? What is my answer going to look like? How far does x have to be from 4? I'm sorry? How do you write that? less than what? Right? How far does x have to be from 4? That means the distance from x to 4 has to be at most how big? Right? I'm sorry? Smaller than 2?
No, for your previous.
Oh, this has to be 2. Thank you. Thank you. Okay, so that's where I want to get, okay? Right. There's 2 ways to proceed. You can either solve for x and then figure it out. But in this case, it's pretty easy to see that if I divide by 3, I'm good. I divide the left side by 3, I get x minus 4. Divide this side by 3, I get 2/3. So how far away? At most 2/3 away. Right? So that means I can go maximum of 2/3 this way from 4, or 2/3 this way from 4. And as long as x is there, my y will be within 2 units of 14. Okay? Does that make sense? Okay. To say that the limit exists means I can solve this problem for any number here. I'll always be able to find a number here that would make that happen. Okay? If I can do that for any number where the 2 is, then I have a limit. But if I want to do that for every single number in the world, I couldn't do that, right? So I have to introduce a new symbol to represent all positive numbers. Okay? Okay. So let's write the answer here. Here's the answer. I'm going to say it in words. I'm going to write it in math. Okay? Just try to follow along here. If x is at most 2/3 units away from 4, then f of x will be at most 2 units away from 14. That's the answer to the question. I'll say it again. If x is at most 2/3 away from 4, then f of x will be at most 2 units away from 14. Okay? Is that clear? Mm-hmm. Now, something to notice here. This number that we got, right, that controls the distance from x to 4, depends on how close I want f to be to L, right? So this number depends on this. Okay. Since f of x can be made as close to 14 as we want, okay, then we can say this. Given a positive number, any positive number you want. Remember where I wrote anything? Now I'm going to give it a name. Given any positive number, okay, however small you want, okay, it's called epsilon. Doesn't really matter. Okay, we can make f of x minus L less than that number. In fact, we can make this less than anything, right? So as long as this is positive, however small it is, I can always make this happen. By making 14 here, right? By making this small enough, okay? The small enough portion, whatever this number is, has to depend on what? Has to depend on this number, okay? The symbol we use to represent how close x is to 4 is the Greek letter delta. Okay? Yeah.
X minus equals delta, or C
X minus 4 less than delta.
less than delta?
Yeah. Some books put a little subscript of epsilon here to indicate that this number depends on this, right? For me to control x good enough, well, I need to know how good I want y to be, right? So some books write delta sub epsilon.
Excuse me?
Yes.
When you say we can say the given epsilon is greater than or equal to 0, what is that? What's small?
However small.
Thank you.
However. Is that better? However small, right? Okay. This epsilon delta stuff is very interesting. But always think of it in terms of measuring closeness. Formal definition. Here's the formal definition for limit. Okay? If for any epsilon greater than 0, okay, there exists the number delta such that making x close enough to c, okay, forces f to be close enough to L that we want, then we say the limit of f as x goes to c is L. What part of this formal definition contains the equivalence of what we previously said as close as we want? What part of this translates to that? Yeah, we said that we can make f as close to L as we want. What part of this definition tells us that?
The epsilon.
This part. Any epsilon. Okay? So we can make this as small as you want. You pick an epsilon, I'll make sure this is less than that. Okay? And all I have to prove to you is that there is a number here, okay, that would make that happen. Okay? That making x as that close to c forces f to be that close to L within that many units.